Okay, so now that we talked about the exponential growth model, we're going to use that and apply it to a real-life situation. If you can read this problem on the board, this goes along with example 4 in your textbook. In 1996, there were 2,573 computer viruses. During the next 7 years, the number of incidents increased by 92%. So we want to write an exponential growth model, giving the number n of incidents t years after 1996. In order to write that model, we have to identify what our different variables are that are going in there. Okay? So we are given that the number of incidents increased by 92%. That's going to be our r. R is always a percent, but we don't want to use it as a percentage. We want to change that into a decimal. So 92% as a decimal, if I move that decimal point 2 places to the left, we get 0.92. So that's going to go in there for R. Okay? Then it says in 1996 there were 2,573 viruses. That's our starting amount, okay? Because this model is going to represent the number of incidences after 1996. So we start with how many there were in 96. So we're going to let that be our A. So we're going to say n equals 2,573. And we can simplify this a little further. 1 plus 0.92 is just 1.92. Okay, so that's our model. We don't have anything for n and t yet because it says this model should represent the number n of incidents t years after 96. We don't know how many there are in 96. Then we're going to do the next part about how many incidences were there in 2003. So that information is going to represent our t because we are given a number of years. But our first thing is we have to figure out how many years after 1996 that would be. Okay, so in order to figure out how many incidences there were in 2003, we had to figure out how many years after 1996 that is. 2003 to 1996, that's 7 years after 1996. So that is going to be our t, as you can see right here in the green. That t is in years, and in order to use this model, t has to be in years, so we are good. From there, it's just a matter of simplifying. Don't forget, order of operations. I have to raise this 1.92 to the 7th power first. So once I go 1.92 to the 7th power, then I'm going to go times 2,573. And that's going to give me about 247,485 incidences. And you can see that definitely increased. Okay, which is kind of scary when you think about it. Now we want to graph it, and the reason we graph it is to help us make predictions for the future. So our first step in graphing is to identify that A and B value, and then to get a good scale on our graph. Okay, so we went through our model, we predicted how many incidences there were, or we didn't predict, we found out how many there were in 2003. Now what we want to do is we want to graph our exponential model. And if you'll remember from a previous slide, to graph this model we want to use these two main points. And then we can make an XY chart for other points. We want to first graph 0 and then our A value. And according to our formula for exponential growth, the A value is right in front of those parentheses there. So for us, our point will be 0, 2,573. And as you can see on my graph here, we already set up your XY axis, okay? We're going to represent the number of incidents on our Y because that is what is changing over the years. Remember that X's are independent, Y's are dependent. Whatever the Y is depends on the X. So as the years go on, The number of incidences are rising because it's a growth model, okay? So, and then we had to make sure we had a logical way to break up this graph. I'm not going to count it by every single one if I'm talking about the 100,000s here, okay? But these are just years after 1996. And we also have labels, definitely important for this type of a problem. Okay, so now we're going to estimate. We have 0, 2,573, so that's going to go, you can see this is 50,000, half of that is 25. So this one's pretty low there, it's going to go right about there. Okay, and that is in 1996. That's what we have. Now, we're going to graph the second point. This one is 1, and then our b value. And if you remember from before, the b value is whatever these two numbers are multiplied together. And that's again from a previous slide. Okay, so we're going to multiply those two together. We do that and we find 4,940.16. That's going to be our other point. And then again, we're going to estimate that. That's 1 year after. It's still pretty low, but it is higher. Okay, from here, what you're going to want to do to get those other points is you're going to want to plug in 3 years for your t and solve. 6 years just to get some more points. But we know this is an exponential growth model, so we are going to rise. Another thing you can do is plug this equation into your calculator. Make your n become your y, and your t would become your x. And you can get points right off of your table, just like we've been doing in class. And last, we want to estimate the year when there were about 125,000 computer security incidents. We can use our graph to estimate. It's not going to be accurate. So they want